Here's how to draw the cardiac cycle if you are asked to do so during your primary FRCA Viva. Start with your axes. Pressure on the y-axis labelled millimeters of mercury up to 120 and time on your x-axis. We'll start with the left ventricular pressure waveform, and it begins with a little bump during atrial systole. The atria contract and squeeze a little bit of extra blood into the ventricle, and that causes a little bump in pressure. Then we're going to do a smooth curve up to 120 millimeters of mercury, and we'll describe what happens along the way. As the pressure here exceeds atrial pressure, the mitral valve closes. Your aorta is sat at around 80 millimeters of mercury in an average person, so your aortic valve is not going to open until this point here. And as a result, there is no loss of volume during this time because you've got closed valves. So this is isovolumetric contraction, meaning the volume stays the same. There's no loss of volume as the blood is still in the ventricle. None of it has started leaving the ventricle yet. As soon as the aortic valve opens, you're going to get rapid ejection of blood into the aorta, followed by a period of slow ejection as it empties, and the last blood to come out of the ventricle is coming out slower than it initially was. Pressure in the ventricle is then going to drop, and as it drops down to below aortic pressure, this is when the aortic valve is now going to close. And the pressure in the empty ventricle continues to drop very rapidly. And as soon as it gets to below the pressure of the atria, the mitral valve will open again. And that's our cycle. And then as the ventricle starts to fill up again, you get that slow increase in pressure, followed by your atrial systole again, and the whole cycle starts again. So your key stages are atrial systole, mitral valve closes, isovolumetric contraction, followed by the aortic valve opening. Then you've got rapid ejection, slow ejection. Here the aortic valve closes again because this is where the aortic pressure is sat. Pressure drops, mitral valve opens as it drops below atrial pressure, and the cycle begins again. In this part here, again, you've got both valves closed, so this is isovolumetric relaxation. You might get asked to add the aortic pressure waveform on top of this, so if you're going to do that, you start at around 90, and during atrial systole, when there's no flow into the aorta, there's a gradual drop in pressure down to about 80. And then it meets the left ventricular pressure, and at which point you've got rapid ejection, so obviously the pressure's going to shoot up, and it pretty much follows the left ventricular pressure waveform all the way up and over the hump because they're matching each other's pressures until we get to the point where the aortic valve closes, and this is where the closure of the aortic valve maintains the pressure in the aorta while the left ventricle relaxes. So that pressure is maintained and you get this sort of dichrotic notch, a slight extra bump. This is a Wind-Kessel effect. So this is where the musculature of the wall of the aorta kind of rebound and maintain that pressure. So you get an extra little bump, and then that will slowly drop back off again to meet the start of the graph at 90. So the aortic pressure waveform looks like your arc line trace. So you've got your initial systolic pressure, your dichrotic notch, and that extra pressure. And if they ask, this is the bit that gets augmented by an intra-aortic balloon pump, but they might not ask you that. And then it relaxes away. If they're being really cruel, they might ask you to add the atrial waveform on top. This is basically a JVP waveform, and it just sits at the bottom. So this is your pressure in the ventricle, which is going to be the same as the atrial systolic pressure because the blood is flowing from atria to ventricle, therefore the pressure must be equal or slightly higher. So you've got your atrial waveform is here, and that's your A wave, which is atrial contraction. Then you have your C wave and your X descent. So your C wave is as you get the isovolumetric contraction, the contraction of the ventricle pushes back on the wall of the atria and causes a slight rise in pressure. X descent is as all the blood shoots out of the ventricle, it actually pulls the mitral valve downwards and away from the atria, so you get a slight increase in volume of the atrium and therefore a drop in pressure. And then you've just got slow filling, which forms your V wave. This is just slow filling, and then as it meets the ventricular pressure on the way down again, then you get your Y descent, which is the blood passively filling from the atria into the ventricle. you probably won't be asked that much detail, and you definitely won't be asked more. But if you are familiar with these different steps and stages, and you can vaguely explain what happens and when the valves open and close, then you'll be well on your way.